All right, we're going to look at solving a problem here where we're trying to find a 98% confidence interval for mu1 minus mu2, given the following information that we're giving what x bar is, what the sample size, our first sample size is 20, with a mean of 2.73 and a standard deviation of 0.032. And N2 is 40 with a sample size, a mean of 2.59 and a standard deviation of 0.91. And what we're trying to do is find a 98% confidence interval for the difference between the two population means based on these two sample means. We've got two different populations, maybe two different groups of students, and we're wondering if there's a significant difference in their GPAs. One group has a GPA of 2.73, the other group has a GPA of 2.59, and we took random samples, and we want to know how big is that difference, what's the size, the difference between those two things. So our first estimate for that is mu1 minus mu2 is x bar 1 minus x bar 2. And so our best guess for the difference would be 2.73 minus 2.59, which is 0.14. So my best guess is that the first group has a GPA that's 0.14 higher than the second group. The GPA of the first group is 0.14 units higher, but we also want to add a margin of error to that, and that's the way that this problem is looking for. It's looking for that number plus or minus number sort of thing, format for the confidence interval there. So I know that my first guess would be 0.14. That's our best estimate for the value. But what I also need to do is calculate the margin of error. The margin of error is going to be t star times the square root of s1 squared over n1 plus s2 squared over n2. And what we're doing is looking at how do you find the t star. We've got values for s1 and s2 that we can plug in, but we don't know what t star is. But we're looking at a 98% confidence level is what we're looking at. So what we're looking for on our t distribution, like the normal distribution, is a nice bell-shaped curve. It's got a little bit more area out in the tails, but it has that same general nice symmetric shape. And what we're trying to do is we're trying to find, well, how far out do you have to go from zero, or from the mean in general? How far do you have to go to capture 98% of the population? We're looking for what are these two t stars down here. One's going to be positive, one's going to be negative. And so we have to kind of do a little bit of thinking before we can just plug this into our calculator. What I need, the calculator wants the area to the left, and so probably the easiest area to the left of that we're looking at is this minus t star here. And I need to know kind of what's the area to that left. Well, if 98% of the values are here in the middle, because we're doing 98% confidence, we want 98% of the values. We want to know how far out do you have to go to capture 98% of the values. That leaves me 2% that I don't have accounted for, and that 2% is divided evenly between the two sides. It's nice and symmetric. So 1% is going to be over there, and 1% is going to be here on the left, 1% is going to be on the right. So when I go to my calculator, I'm going to use the inverse t command to get the t-score, and you have to feed it the area that's to the left. So you can either do 0.01, that's probably the easiest one, is to just do 0.01. And then the other thing you need to feed it is the degrees of freedom. And that would be the conservative estimate is just to do one less than the smaller of your two sample sizes. So here I've got a sample size of 20 and a sample size of 14 or 40. So I'm going to take one less than the smaller of those two. I'm going to use 19 for my degrees of freedom. So that's the command I want to do on my calculator. Let me get to that. That's not what I want to do. I'm switching between new things there. I want to switch between programs. There's my calculator. And so what I want to do is I want to go into distribution. It's up here above the VARS button. So I want to press the second and then the vars. And then there it is, the fifth one down, or fourth one down is the inverse t. So I'm going to come down to inverse t. I'm going to select inverse t. And my percentage, the area that I'm looking at, is 0.01. The degrees of freedom that we have is 19. And some calculators, there's a different thing where you have to put in the mean and the standard deviation. Start with the basic mean of 0 and a standard deviation of 1 to get your t-value. And then when you hit the enter, it'll spit out your t-value. My t-value here is a minus 2.5394. 2.539 or 2.5395. We'll use 2.5395. So I'm going to switch back to my other, where was I? There's where it was. And so t is equal to, my t star is going to be 2.53, I forgot what it was. 5395. 2.5395 for my t-star. I'm going to use that for t-star. It does come out negative. We'd expect it to be a negative here on the left-hand side of the value. And so we're anticipating that negative value. You could do, if you want to see the positive one, you could do inverse t of 0.99. The area to the left of this positive t value is 0.99, and it will turn out to be the positive value, 2.5395. But I've got the plus or minus in my equation. I just take the positive one. You've got the plus for this side. You got the minus for that side. That's what you need. So that's what I want to plug into my formula. 2.5395 times the square root of S1, which is 0.32 squared, divided by N1, which is 20, plus 0.91 squared divided by 40 there. And so that will give me my margin of error. That'll give me the value there that goes in that value. So let me swap over to my calculator here and actually do that. So I want to take 2.5395 times the square root, and you do want to capture all this stuff underneath the square root. 0.32 squared divided by 20 plus 0.91 squared divided by 40, and then close parentheses to end that square root. And the calculator will follow the order of operations. You don't have to worry. It's going to do the exponent first. It's going to divide, do the division, then it's going to do the addition, just like the order of operations says. And then with the big parentheses there, grouping it all underneath the square root, it'll happen the way we want it to. And so it looks like I'm getting 0.41. The question that we're looking at in particular asks you to round to 2 decimal places. So 0.41 for my margin of error. So that's what we should end up with. Let me go back to, I don't know what I just did there. We go back to here, and it was 0.41 was my margin of error. So my difference would be, my confidence interval would be that I'm 98% confidence that the proportion of, or the difference between the two GPAs in the two groups is 0.41 plus or minus it's 0.14 plus or minus 0.41. So it doesn't seem to be that this overlaps 0, the possibility that there's no difference between the two groups. So I'm seeing a difference in those 2 sample means, but because my confidence interval goes both positive and negative on there, I'm going to say that there's probably not a significant difference in there. It could go either way. There's not a big enough difference between those two to say that it's important or significant, I should say. I shouldn't say important.